Bismillahirrahmanirrahim. Good afternoon, everyone. Today, our lecture will talk about Kirchhoff's laws and how many types we have, and we will explain together the important information about all of them and why we use it, what the benefit from it, and we have important example. I take it from source and I put it the source picture at the last slide from this from this lecture. Actually, I'm recording at 11 p.m. Now, let's keep going. Let's go to another slide. Here, the scientist is Gustav Kirchhoff. Here in 1845, a German physicist. This guy belonged to German country, developed peer rules. We will explain all of them at the next slide, which deal with the conservation of current and voltage, because that we have two kinds, and one of them with dealing with current and the other dealing with voltage, and we will explain all of them at the next slide within electrical circuits, or we can say closed circuits. The two laws are commonly known are Kirchhoff's law. The first one is dealing with current, and we can say KCL, that's mean Kirchhoff current law, dealing with the current flowing around a closed circuit. A closed circuit, that's mean the node, or we can say at the same time junction. And like we're seeing here, we have 5 currents, 3 of them going directly to the node, to the closed circuit, because that all of them will have positively charged. And we can say in currents. And at the same time, the last 2 currents going far away from this closed circuit or from this node, because that we can say out currents. And at the next slides, we will explain together. We have 3 kinds of situation like that. At the first time, all of these currents will be at the same side. All of them will be going directly to the current. The second type, all of them will be going far away from the closed circuit. And the last one will be mixed. That means some of these currents will go directly to the closed circuit, and the other will going far away from this closed circuit or from this anode. Now, what is the Kirchhoff current law? The Kirchhoff current law is the state that algebraic summation of all currents entering and existing a node must equal 0. The summary to these 2 statements here, when we're dealing with KCL, that means summation in current must equal summation out current. But actually, when we start to solve the examples, we will say that's right, the same result, but opposite charge. Summation of entering, that's mean positively charged because go directly to the closed circuit, equal summation of exciting current, and these currents have minus charge, negatively charged, because going far away from this node, that means this node will be something like base to us to can understand, to can determine the charge currents. Now let's solve these questions. Why we use Kirchhoff's current circuit law, KCL, why Kirchhoff current circuit law is important, what is its advantage. Actually, all these 3 questions have the same solution. Here, the first important thing, Kirchhoff current law allow to us to solve complex circuit problems by defining a set of basic network like Law's theorems. Like I said before, we have 3 theorems. I will explain all of them at the next slides for the voltage and current around a closed circuit. And at the same time, by use KCL law, we could describe how a charge enters and leaves a wire junction. I use this slide. Why? Because when we start to solve the examples, the next slide, we will dealing with source like that, has the same figure. Because these figures, we can determine this source as independent or independent. Okay, here all of these are independent voltage source or current volts. Here, when we dealing with independent voltage source, that's mean we will dealing with 2 different terminals, positively and negatively. But here we will dealing with arrow, start from point going to another point. That's mean here independent current source, like we're seeing here, and dependent voltage source, dependent voltage or current will be at the same shape like that, not cup, but like that. And if we're dealing with dependent voltage, that's mean we're dealing with 2 different terminals, positively and negatively. And when we when we dealing with dependent current source, that's mean we will say arrow from point to another point. Here, this example, a simple example, let's solve it to can understand all this simple information. Here we have 3 currents, I1, I2, I3. I1 equal 10 ampere, I2 minus 4 ampere. I3, we don't know I3's result because that, let's go directly to this rule to can calculate result of I3. Summation I equals 0. What that summation I here? We have 3 currents. Summation I, that's mean I1 plus I2 plus I3 equals 0. I1 10 ampere, I2 minus 4 ampere. We don't know what the last result about I3 equals 0. Here we have equation has just one unknown element because that here I3 will equal minus 6 ampere. What does mean? That's mean here this input current, or here when I say minus 6 ampere, what does mean? That's mean here the current will go far away from this closed circuit. That's mean all of them, I2 and I3 will act the output current. What does mean? That mean input current equal 10 ampere equal output equal minus 6 plus minus 4. That's mean minus 10. That's mean input equal output, but with different charge. Now let's talk about, I take this information from the source. I put it the source picture at the last slide. Let's go directly to 2.2 and explain what the Kirchhoff accumular yasasını formal tanım. That's mean formal definition of Kirchhoff law of currents. We have 3 theorems, like I said before. The number 1, we will dealing with many currents, all of them going directly to the closed circuit, to the node. And depending on equation 2.1, here we can say A1 plus I4 equal A2 plus A3. By that, we can we could definition equation 2.3, I1 minus I2 plus I3 minus I4, and we will put I5 to make this equation equal 0 because all of them equal number, and I5 equal the same number but different charge because that equals 0. And the theorem number 2, all of these currents will go far away from this closed circuit, from this anode. And like we're seeing here, we depended on 2.2. And after that, just put it minus with any odd currents. For example, 1, 3, 5, put it minus, and put it positive charge beside any even current like 2 and 4. The last result to equation 2.3 equals 0. Here the last one, the last theorem is, here we dealing with mixed currents. That means some of them going directly to the closed circuit and the other going far away from the anode. Here we have 5 currents, 3 of them going directly to the anode. What that means? That means input current, and the I2 and I4 will act the output current. What does mean? That means here I1 plus here what I1 plus I3 plus I5 minus I2 minus I4. That's right, 2.3. And we could definition equation 2.5. Here, just we will put the minus elements outside close. Yes, we can take the minus elements and put it in the next side to make this equation be I1, I3, I5, the input charge, input current, equal the output current, I2 plus I4. Like we see here, just we have 2 currents go far away from this node. Here, there's some important exam. Let's try to solve it. Like I said before, I used the last slide to explain the independent and independent source, and we will take more details at the next slide. The next lecture will be inshallah tomorrow. I will explain the dependent current source, and after that I will use the same slide to explain the another information. Now let's keep going. Here VS is the independent voltage source. Here independent voltage source, because like I said before, we're dealing with 2 different terminals and 3 different resistance. And here, like I say, VS, that's mean here IS, I1, I2, I3, and IG with this voltage source, VG. And let's keep going to determine, let's going to determine the VB equation. And after that, when we can calculate, when we can determine VB equation, we will start to calculate to determine the results of I1, I2, I3. That means VB, that's what the voltage at B point will be very important to us to calculate the other current results, yes. Now let's start. I1 what? I1 equal what? Equal I2 plus I3, okay? Here I1 acts input current, I2 plus I3 acts output current. After that, IS equal, here I2 equal ij, equation 2.6. And here we will put summation, we will calculate all of these three currents, and all these three currents are equal 0. IS plus I2 plus IJ equals 0. Here from Ohm's law, what that Ohm's law? Ohm's law, it was V, the different, the voltage equal current times resistance. Because that I equal V divided on R. But here we will take all of these three currents alone. What does mean? I will start from I1. I1 here dealing with voltage VAB because different potential between two different points. That's mean I1 equal VAB divided on R1 and equal VA minus VB divided on R1. Let's go to I2. I2 dealing with different potential with different points. VBC, that's mean equal I2 equal VBC divided on R2. That's right, equation 2.7b. Now let's go to the last current, I3. Where's I3 here? Dealing with potential VBD divided on R3, that's mean VB minus VD divided on R3. It's equation 2.7c. By using independent voltage sources, what does mean? Here, VS, where is the VS? This is VS. VS equal VAD. Let's go see if this is right or not. VS equal VA minus VB. What does mean? That's mean the different potential between AB, that's mean VAB. Let's go to see VG what equal. VG equal VCD, that's mean VC minus VD. Let's go to see if this is right or not. VG equal VCD equal VC minus VD. The different potential between these 2 points, CD. Selecting the enable node as a reference, VD will equal 0. That means we will delete VD here, any VD, because VD at the enable node equals 0. VS equal VA minus VD. Here maybe I did some wrong because VS equal VA minus VD, not VB. Okay? Because that VS will equal VA because VD, like I said before, equals 0. And after that, VG equal, like I said before, equal VC minus VD. Yes, this wrong. Here I must write D, VCD equal VC minus VD. And VG will equal VC because VD equals 0. That's great. Let's put these two results, VS equal VA and VG equal VC, sorry. What will happen? I1 equal VS minus VB divided on R1. I2 equal VB minus VG divided on R2. IS, VD equals 0, will be equal VB divided on R3. That's great. That's very important three equations, and the last important equation will be the result of VB. Here, let's calculate all of them. Let's calculate, let's prove by proving the input current equal output current, like I said before, input current I1, output current I2, I3, that's mean I1 equal I2 plus I3, and let's put all of these results, three results here, will be like that. Vs minus Vb divided on R1 equal Vb 9 minus Vg on R2 plus Vb divided on R3. After that, by using some tricks, Vb equal, like we're seeing here, equal 2.11, equation number 2.11. That's the last important equation to us. And honestly, it's very important to us because without it, we can't determine the results of I1, I2, I3. Now let's calculate the result of Vb equal 8 volts. By it, we can calculate I1 because equal Vs minus Vb divided on R1. Vs, we know the result. The author gives it to us. Vb equal 8 divided on R1. 2 ohm equal 3 ampere. V2 equal Vb minus Vg divided on R2. Vb 8 volt minus 10 volt divided on 3 equal 1 ampere. I3 equal Vb divided on R3 equal 2 ampere. Now, is Kirchhoff law applicable to AC? Actually, Kirchhoff law applicable can dealing with DC and AC circuits. They can be accurately used for DC circuits and low frequency AC circuits. And let's talking shortly about the second kind of Kirchhoff. The second kind of Kirchhoff dealing with the voltage with closed circuits. And we can say KCL. Sorry, that's we was still talking about KCL. I'm sorry, deals with the, here maybe I have wrong. The Kirchhoff voltage law, KV, Kirchhoff voltage current. Yes, that's right. Now we're talking about the second kind of Kirchhoff law. Second kind of Kirchhoff law dealing just with the voltage with closed circuit, dealing with voltage sources present in a closed circuit. This diagram explained to us, and like I said before, this figure, this shape told us here we were dealing with independent. We're still dealing with independent source, but here we're dealing with independent voltage source. And the same idea, but here with the voltage, the V out equal summation Vn, and we will see that in any closed loop network, then total voltage around the loop is equal to the summation of the voltage drops within the same loop, which is also equal 0. That's mean, like I said before, out voltage equal input voltage and equal 0. Summation in volt equal summation out volt and equal 0. This ideal by Kirchhoff is known as the conservation of energy. Here it's the last slide. Our lecture is done. I take many of these information from the internet, and about 2.1 and the other, for example, when I explained and solved the example, I depended totally 100% on the source. Devra analyze beer. And the author was Prof. Dr. Mehmet Onder. Our lecture is done. Thank you about your watching, your patience. Inshallah, tomorrow I will record another lecture to explain the dependent current source. Thank you so much again. Have a good night.